to take a derivative. So given this function, which I'm going to take a look at the graph first, well, I need to adjust x and y for that. It seems that we have a parabola, and when theta equals 0, find the derivative right here. So derivative dy dx means the slope of the tangent line. That looks like it would be a slope of maybe 1. In fact, we could ask the calculator how much is dy dx at that point. Oh, what a guess. Dy dx is equal to 1. Now let's actually prove it. So we can use formulas like x is equal to r cosine theta and y is equal to r sine theta. Those two equations are always true. Then, in our case, we can take this, substitute it in for r. So x is going to equal the 6 over 1 minus sine of theta times cosine of theta. And then just separate these. The y is going to equal 6 over 1 minus sine of theta times sine of theta. And no, these cannot cancel out because this one says 1 minus sine, not just sine. So then we need to take the derivative. That's going to give us the dy part. Take the derivative. That's going to give us the dx part. And later we'll divide them. So in here, I don't want to use the quotient rule on this. It's not really that complicated. So I'm going to rewrite it as 1 minus sine of theta is to a negative 1. X is equal to 6, and then 1 minus sine of theta to the negative 1 times cosine. So over here, use the product rule. So we would get dx d theta is equal to, take the derivative of this, it's going to be negative 6, and then 1 minus sine of theta is to the negative 2. You then need to take the derivative of the inside, which is going to be negative cosine of theta, and then leave this cosine of theta alone. So at this point we're halfway done with the product rule. Then say plus, this time leave the 6 and 1 minus sine of theta to the negative 1 alone, and then take the derivative of this, so it's going to be negative sine of theta. And for finding dy dx, we're going to be dividing the derivative of this and this derivative, and then plugging in 0. Or you could plug in 0 right now, and then divide the numbers later, which is what I think I'm going to do. So dx d theta, sometimes it's even written like this, evaluated theta equals 0 is going to be, so this is going to be sine of 0 is 0, so that means in the denominator I have a 1 being squared. So that is just going to be negative 6 divided by 1, so we've got negative 6. Then cosine of 0 is a 1, so that's going to be a negative 1, which is going to get rid of the negative. And then cosine of 0 is a positive 1, so multiply this by a positive 1. Next we've got, again, this is going to be sine of 0 is 0, so we've got a 1 times a 6, and then times the sine of 0 is 0, so the only thing that's left is that 6. Now find the derivative of y with respect to theta. Again, I'm going to take the derivative here first, so negative 6. The inside part stays the same, and then it's raised to negative 2. Then take the derivative of the inside, will be negative cosine of theta, and leave that sine of theta alone for now. Plus, leave the 6 and 1 minus sine of theta to the negative 1 alone. This time take the derivative of sine, which is cosine. And then how much is dy d theta evaluated at theta equals 0. So let's see, all of this part is almost the same as the last story, except this time we have it times sine of theta. So sine of 0 is going to be 0, which means all of this gets wiped out. We're only left with this. So this is going to be, here sine of 0 is 0, so we're only left with a 1 times 6, and that 6 gets multiplied with cosine of 0, which is 1. So 6 times 1, 6. And then finally, when you divide them, you get dy dx. The thetas are now gone. So it's 6 over 6, which is 1, which is what the calculator told us about 5 minutes ago.